Okay. Well, let's pick up where we left off then. So let me just quickly review what we were going over. This is all about solving trig equations. So we'll get a relatively simple equation like this, and we talked about there are lots of different ways to solve these. You can draw triangles, you can think of the unit circle, you can draw graphs, you can have your calculator help you. But one of the difficulties is your calculator is only going to give you one answer if you use a sine inverse. And we talked about this before. On this particular problem, it will only give us this answer right here in quadrant 1. Okay, it gives us the 60-degree answer. It doesn't give us this one over here that's 120. So we said your calculator will give you answers in quadrants 1 and 4, but you've got to use your brain to figure out that these other ones could also work there. Okay? We also pointed out another problem with sine inverse, and that is sometimes it will give you answers in quadrant 4. So let's say, for example, it gives you this answer of negative 45. Okay? Is that the answer you use? It's not. You have to do two things with that answer. If this was the answer that you got when you were solving it using your calculator, you'd realize this. Your calculator gave you an answer over here, but there's another one over here that works. And you'd have to recognize that this reference angle is 45 degrees. So this reference angle is 45 degrees. So that answer right there would be 225 degrees. And we wouldn't use the negative 45. We'd use one that's coterminal with that, that's positive. So what's coterminal with negative 45 degrees that's positive? 315. Okay? So those would be the two answers if they said write down the answers between 0 and 360 degrees. If they said write it down in between 0 and 2 pi, of course, we'd write the radian equivalent for each one of those, which would be, quickly, 5 pi fourths and 7 pi fourths. Got to be really quick with those still, okay? Now, if it said write down all of the answers in radians, this is what we'd write down. We'd write down 5 pi fourths plus 2k pi. That would be the first answer set, and the second answer set would be 7 pi fourths plus 2k pi, okay? And that would be all of them. So you've got to pay attention to the instructions. You've got to be very careful in if you use your calculator or if you graph it or different things like that. You've got to make sure that you identify all the answers, okay? Ring a bell, especially to that person that did one problem on it over the weekend. Okay, who did at least one problem on this over the weekend? Like a hand and a half over here? Okay. Wow, that's very impressive. Very impressive. Then let's do this. Because here's what I've got to finish up on the notes. We got to the second side, and there are 5 problems that I'd like to do, all of which are, I mean, they're a little more challenging than the first side. Let's do 16. No. Is 7, 8, 9, 10, or one of those assigned? 7. Do number 7, please. Okay, go ahead and do number 7. Right now, everybody do number 7. Okay, those are the instructions. It says find all the answers. So find all the answers in radians. How's it coming there, Sven? Cameron, what do we do first? Subtract the 1, so we've got 2 cosine x equals -1. And then Brandon, what do we do after that? Divide by 2. So we get cosine of x equals -1/2. And then Peyton, what's next? What do we do next? We could draw the unit circle. That would be one approach. Draw the unit circle so it looks something like this. And the cosine is negative, and Peyton's talking about which coordinate?
Second and third.
Those are the quadrants, but you're talking about the x coordinate, right? So the reason it's got to be on the left side is the x coordinate is negative, right? So we could draw a triangle over here where this is -1/2. And he said the second and the third, this one down here also has an adjacent side or an x coordinate that's -1/2. It's the unit circle, so that's 1 and 1. And this is radical 3/2, and that's negative radical 3/2. Why do we not care that this one's positive radical 3/2 and that's negative radical 3/2? We're focusing on the x. We're using the cosine. It's the cosine ratio that's most important. That means this is the long leg. That means this angle right here, this reference angle, is how big? 60 degrees. Okay? Which means what is the measurement of that angle from standard position? 120, or if we're going to answer in radians, 2 pi thirds. So there's one answer. Okay, and then this reference angle would also be 60. That would make this 240 degrees, or in radians again, 4 pi thirds. Okay, and then is this all the answers? Nope. We have to acknowledge the fact that we can go around the circle again and again and again. So that's going to be 2 pi thirds plus 2k pi. And the other answer set's going to be 4 pi thirds plus 2k pi. There we go. Raise your hand if you got that right. All on your own. Very good. Okay. All right, any questions there? Okay, we'll come back and we'll take a look at number 16 in just a minute. Let's take a look at the back side of this. These get a little bit more challenging. It does say you only have to get answers between 0 and 2 pi, but that can still be a bit of a challenge. So let's take a look at this one right here. We talked about how to approach this before. Anybody remember? You've got to factor it, but even to factor, take a good look at it. Got a cosine here, got a sine here. Oh my. So we have the opportunity to change it into something we can factor, okay? So, any ideas? Maybe. Even before that. If you see a trig function squared, it might be a good idea, not always, but it might be a good idea to use the Pythagorean theorem, or the Pythagorean identity. So in place of cosine squared, we're going to put, what is it? Is it sine squared minus 1, 1 minus sine squared? Okay, it's going to be 1 minus sine squared x. And then this is plus 2 sine x minus 3 equals 0. So this is going to be 2 minus 2 sine squared x plus 2 sine x minus 3 equals 0. Now, here's what I'd like to do. I don't care how you think of this. I really don't like factoring things that have a negative squared term. Okay, that's kind of a pain. So we could move everything over to the other side, okay, or we could collect like terms and then just multiply everything by a negative. Okay, so I'm going to do this. I'm going to collect like terms. I'm going to have negative 2 sine squared x. This is going to be plus 2 sine x. And then if I put the two of these together, that's going to be minus 1. And that equals 0, right? Doing okay? Okay. I don't like that negative there, so I'm going to multiply everything by a negative, which is going to change that to a positive, that to a negative, and that to a positive, right? So I'm going to change that to a positive, that to a negative, and that to a positive. Everybody good there? Okay, now the good news on this one is that I'm not going to make you finish it. We're just going to talk about how you'd finish it, okay? And you can watch and write this down if you want to. I wouldn't put one that's this difficult on a test, okay? At least to start with. I mean, it wouldn't look like this and have to do all of these steps just to get to a point where you can potentially find an answer. So here's what you've got to ask yourself. Does this factor? It doesn't, because if you multiply those two numbers together, you get a positive 1. Sorry, positive 2. And you'd need numbers that multiply to be a positive 2 and somehow combine to be a negative 2. Are there any numbers that do that? Multiply to be a positive 2, combine to be a negative 2. Nope. Okay, so guess what you have to use to solve this? The quadratic formula, okay? So you'd get something like this. Sine of x equals negative b. What's in front of that variable term? A minus 2, so this would be a plus 2. Plus or minus b squared. So that's going to be 4 minus 4 times a times c. And remember when we were doing these, I said you need to be really careful right here. I wouldn't skip that step at all. So this is going to be a 2, and that's going to be a 1. And the denominator is going to be a 4. Okay, now, take a good look. This is a really, really ugly problem, but what's cool about this, Noah? What were you saying?
I was going to say, and it's an imaginary number.
Yeah, this ends up being 4 minus 8, right? Which means this is an imaginary number. Okay, can we ever take the sine of an angle and get an imaginary number? So sine of x equals imaginary. No solution. Kind of nice when that happens. If you made a silly mistake like that and messed up on this and turned this into a plus and got 12, then it would be an absolute nightmare to finish off. Okay, but let me show you really quick what might happen. Okay, let's say, okay, this is the answer to this one. I'm going to change colors. Let's say that you used the quadratic formula and you got two things. We got the sine of x equals, let's say it was 1 plus or minus 0.3. Those type of answers can come from the quadratic formula, right? Okay, well, if it was 1 plus that, it would be the sine of x equals 1.3. If it was 1 minus that, it would be the sine of x equals 0.7. Everybody good there? Okay, take a good look at this. We're plugging in an angle, and we're getting a sine ratio that's bigger than 1. Does that ever happen? Nope, it doesn't happen. In fact, remember what the sine curve looks like. And 1.3 would be up here, right? It would never touch. So what's the answer that comes from here? No solution, okay? What about this one? That one does have answers, but is it an answer that we recognize? Okay, is it one of those radical 2 over 2 or something like that? Radical 3 over 2, 1/2, 1, 0. It's not one of those, so it's not something that you could solve using a triangle or a graph, a unit circle, okay? So how would we get the answers from this? What? Calculator. Wow. That's exactly what you do. You can't find the answer to this just by thinking about it. You're going to have to use a calculator. So on your calculator, type in sine inverse of 0.7. And the instructions still say we have to answer in radians. So let's think about how we'd answer this in radians. You've got to have it in radian mode. And what does it say? 1.5? 0.775? 0.775?
Yeah.
0.775. Okay. So the answer to this is 0.775. Now, your calculator will only give you answers in these 2 quadrants. So it's saying the answer is 0.775 radians. So that's an angle measure. We could change that into degrees if we wanted to. But this is 0 and this is 1.57, right? So 1.775 would be about right there. So there's our first answer, 0.775. Our calculator gives us this answer. So if we were to write down all of them, which we don't have to on this one because it says answer just between 0 and 2 pi, okay, that would be one answer, and then we'd add 2k pi, but we don't have to do that on this one, right? So there is one of the answers. Is there another answer? And if so, where is it, and how do you find it? So Hop, where is the other answer? The other answer is in quadrant 2, so I'm going to change colors again. Okay, we got to use our brain to figure this part out over here. The other one is in quadrant 2, it's right here. If this angle right here is 0.775, how big is this reference angle right there? 0.775. But how do you figure out how big this angle is from standard position? So what is that answer in standard position? Who knows how to do it? Who knows how to find the answer? Jordan does? Noah? Cameron? Miranda? Miranda, how do you get the answer? No? Jordan?
Wouldn't you just subtract 0.775 from 1.57? Add that to 1.57?
You could do it through subtraction, but it would be a little bit easier. So what Jordan's thinking of is let's figure out what this little sliver is right here and then add it to 1.57. But it would actually be easier. Let's start with pi and let's just subtract the size of that reference angle, subtract 0.775. Remember doing this in chapter 4 when we were talking about reference angles? So on your calculator, type in pi minus 0.775 and tell me what you get. 2.36. So these 2 answers right here, those are it. Okay, those are the only ones between 0 and 2 pi. Okay? So if you had one like that, that's how you'd finish it off. Probably wouldn't give you one like that on a test, though. Okay, any questions? Okay, let's take a look at this one. Let me see here. You know what? Let's skip that one, okay? And if we've got one on the assignment like that, we'll skip that one too, okay? Let's take a look at these because these are a little bit more interesting. This one is very similar to the one that we solved, problem number 7, was it? Very similar to that. Okay, so I'm going to ask Cameron to tell us what to do first. Awesome. So we're going to do 2 sine 2t equals -1. Brandon, can you help us out again? Divide by 2. So I get sine of 2t equals -1/2. Okay, and here's where it gets a little bit interesting. Okay, so everybody watch. Does anybody know what to do next? Okay, there are a couple different things that you can do. I think by far the easiest and the most standard technique for this is, this looks kind of familiar, but this angle right here makes it a little bit strange. If this just said sine of, I'm just going to pick a variable, sine of u equals -1/2, that would be relatively easy to do. Okay, we know how to do that. So here's what we do. We say, let's let u equal 2t. This is called a substitution. Okay, and the substitution technique is used a lot in math. Okay, you will see it over and over again. Okay, most of you said you're going to take calculus. You'll see it in calculus quite a bit. Okay, substitution is used to make something that looks unfamiliar to make it look more familiar. So if wherever there's a 2t, I put a u, okay, let's ignore this stuff right here and let's just focus on this here and let's solve that. So that's, let's see, when Peyton was thinking about this, the y coordinate was negative, right? So if we draw a unit circle and we've got -1/2, that would happen here and it would happen here, right? And if this is -1/2 and that's -1/2 over here, how big are these little reference angles? They're 30 degrees, right? Each one of those is 30 degrees. So that makes this one, let's see, we've got to answer in radians, 7 pi 6, 7 pi 6. And this one over here, 11 pi 6. Okay, those are the two answers. Any questions on that? Okay. Here's why we started off writing down answer sets. When you're doing a more complicated problem like this, it's much better to write down answer sets. So here's what we've got. We've got u equals 7 pi 6 plus 2k pi. And the other answer set is, Brandon, that's not nice, 11 pi 6 plus 2k pi. Now, is the original problem, is it about u's or is it about another variable? It's about another variable, right? T. So we want to write this in terms of the original variable. So we made a substitution. We changed the variables to make this a little bit easier to solve. Now we need to change it back so that we can get the answer in terms of the correct variable. So here's what I'm going to do. Wherever there's a u, I'm going to put a 2t. So this means 2t equals 7 pi 6 plus 2k pi. And that, what's that? It does. I'm going to get to that in just a second. And this would be 11 pi 6 plus 2k pi. Okay. Does everybody agree that these answer sets, once I get rid of the 2, are going to be in terms of t? Okay, now, Hop was just pointing out, doesn't it say we should only have answers between 0 and 2 pi? That is correct. That's what the instructions say. But the hard part about this is, if this is a different type of angle, if it's 2t or t divided by 2 or something like that, or t divided by 4, it's hard to tell how many answers you're going to end up with. Normally, we only end up with 2 answers there. Okay? So let's take a look at this, and let's solve this for t. From this one, we get t equals, if I divide everything by 2, this is going to be 7 pi 12ths plus, if I divide that by 2, I get k pi. On this one, I get t equals, this would be 11 pi 12ths plus k pi. And remember, you can plug in any integer you want. If I plugged in a -1, so if I plugged in a -1 right here, I'd have 7 pi twelfths minus pi. Would that give me a positive or a negative answer? 7 pi twelfths, 7 twelfths of pi minus a full pi. Positive or negative? It would give me a negative answer. Is that in this interval? It's not. So let's start off by plugging in k equals 0. If I plug in k equals 0, I get 7 pi twelfths. Is that in the interval from 0 to 2 pi? Yes, it is, so we're going to keep it. What if I plug in a k equals 1? I get 7 pi twelfths plus 1 pi. So 7 pi twelfths plus 1 pi. I'm going to write 12 pi twelfths. Altogether, that's 19 pi twelfths. And is 19 pi twelfths, is that between 0 and 2 pi? Yeah, 2 pi in terms of twelfths would be 24 pi twelfths, right? So do both of those work? Okay. What if I plugged in a k equals 2? Why wouldn't it work, Brandon? Couldn't have said it better myself. If you plug a 2 in here, that's already 2 pi, and then you're going to add more to that. That's definitely going to be outside our interval of 0 to 2 pi. So we're going to do the same thing on this one. Let's plug in k equals 0 and k equals 1. If I plug in k equals 0, I just get 11 pi twelfths. So there's one of the answers. And if I plug in 1, 12 pi twelfths plus 11 pi twelfths, I get 23 pi twelfths. Okay, now, those are the 4 answers that work. How many answers do we normally get on an equation like this if we're just going from 0 to 2 pi? We normally just get 2. Can anybody explain why there are 4 answers rather than just 2 answers? Jordan. Very good. Excellent. Okay. What does the 2 do to that graph? Changes the period. It makes it cycle faster. Okay. So I'm going to grab the calculator and we're going to look at why it does this, why we get twice as many answers. So when this comes up, here's what we're going to put in here. Okay. So I'm going to go to y equals, and I'm going to clear everything off here. And I'm going to type in sine x, and I'm going to close the parentheses. Then I'm going to type in negative 0.5. I'm going to set up the window, so I'm going to go from, whoops, I need to check the mode. We're in radian mode, so let's go from 0 to 2 pi. We're going to put a tick mark every pi, whoops, pi divided by 4. And then let's go from negative 1.5 to 1.5. So I've got a window a little bit bigger than what the amplitude is, and I'm going to graph this. There's a regular sine curve. Here comes that horizontal line at negative 1/2, and how many places does it hit it in? Just in 2. In fact, the 2 that we found to begin with. Okay, the 7 pi 6 and the 11 pi 6. If you wanted to check those, that would be where they hit. Okay, I'm going to come back here, and here's the only thing I'm going to change. So keep that visual picture there. Oops, I'm going to go right here, and I'm going to insert a 2. What's that going to do to that sine graph? Speed it up. It's going to cycle twice as fast. So if it cycles twice as fast, it's going to dip down below the x-axis twice as much. Here and here, here and here. So you can see those 4 answers that we just got. Does that make sense? Okay, any questions? Okay. That there just as a reminder. Okay, let's take a look at this one then. Ideas on that one? Subtract 1, so we're going to write cotangent of x over 2 is equal to negative 1. What's that? You don't have a cotangent inverse on your calculator, so that's kind of an issue. So, what's that? What do you mean? We are going to substitute, okay? Do you like working with cotangent though? Cotangent's kind of a pain, so here's what we're going to do. I'm going to write this as 1 over the tangent of x over 2 equals -1, and I'm going to make both sides a fraction just so I can literally compare the two of those. So if I had 3/4 equals -6 over -8, first of all, is that true? Is that true? Is 3/4 the same as -6 over -8? Are you kidding me? Okay, the ones that are going like this, the answer is yes, okay? Those are the same. What would happen if I flip this one over and flip that one over? Is that still true? That was much better, much more unison there, okay? So if I take this fraction and I flip it over, this would mean that the tangent of x over 2 should equal, what do I get when I flip -1 over 1 over? I get -1, don't I? So now I've got an equation that has tangent in it. That's one of those buttons we've got on our calculator. That might be helpful. Okay, or, okay, Sven, what were you going to say about this? Okay, we're going to do a substitution. So wherever there's an x over 2, we're going to put a u. So we're going to be solving this. The tangent of u is equal to -1. Now, you can solve that on the calculator if you needed to, I suppose, but you should be able to figure this one out from scratch because we're talking about the tangent, the opposite side over the adjacent side, the y-coordinate over the x-coordinate being negative, -1. And that happens right here and right here. And really, you only need one of them, right? This one is 3π4. This one is 7π4. But how often do each one of them repeat? Every pi, every 180 degrees. So we could get away with writing an answer set that looks like this. 3π4 plus k pi. And again, normally between 0 and 360, between 0 and 2 pi, we get two answers. But the hard part about this is we've got this little x over 2 going on here. So does everybody agree that, whoops, this should be a u, shouldn't it? Okay. Does everybody agree that those are the answers in terms of u? And that there would only be two of them between 0 and 2 pi? Everybody good there? Okay. So I'm going to replace this now with x over 2 equals 3π4 plus k pi. Then I'm going to times everything by 2. So I get x equals, if I times by 2, this would be, well, that would cancel and that would be a 3π halves. And this would be a 2k pi, right? Okay, we already figured out we're not going to plug in negative integers, right? We're not going to plug in -1. What should we plug in first? 0. If I plug in a 0, I get 3π halves, right? What if I plug in a 1, Brandon? Why not? Like what he said before. If you plug in a 1, it's already 2 pi, and then you're going to add something to it. Okay? So I only get one answer that works. Okay? Now, can somebody other than Jordan tell us why we only get one answer that works on this? What happens? It gets slowed down, so it doesn't make as many solutions from 0 to 2 pi. Okay? See how understanding those graphs is helpful here? Okay, last little bit. Okay, let's take a look at that one. It does factor. It does factor. Okay? So we're looking for, let's see here. I need a secant. Let me change colors here so it looks a little better. Secant of x. Secant of x. -5, right? +2. So on this one, what I really want to know is where does the secant equal 5. And on this one, I really want to know, where does the secant equal -2? I'm not nearly as good at secant as I am at using another trig function. Cosine. So just like I did up above, I'm going to take this and I'm going to flip it over and I'm going to make that a cosine of x. If I flip that side over, or in other words, if I make that side its reciprocal, what do I do here? 1/5. If I make that a cosine, what do I make this? Make that -1/2. Now, one of these answers you should already know. Didn't we do one like this a second ago? Didn't we actually solve this very one? And didn't we end up with 2 pi thirds, 4 pi thirds, and so we wrote down the answer sets, x equals 2 pi thirds plus 2k pi, and x equals 4 pi thirds plus 2k pi, right? We solved that one at the beginning. What about this one? What is it, Noah? It's calculator time, okay? Make sure your calculator's in radian mode, and here's what we're going to do. So I'm going to do cosine inverse of 1 divided by 5. Remember, the secant was 5, so that means the cosine would have to be 1/5. It's going to tell me an answer of 1.36. So let's think about that for just a second. 1.36, this is 0, this is 1.57. 1.36 would be about right there. Does that look like it would have a pretty small adjacent side, a pretty small x coordinate? Yep. Okay. So this is 1.36, 1.36 radians. Okay. I'm going to write calculator on here in just a second, and then I'm going to write brain on here in just a second. So your calculator is really good at figuring out cosine inverse. In other words, giving you an angle that makes the right cosine ratio in a couple of quadrants. But it will only do those 2 quadrants. Your brain's got to figure out the other ones. So for calculator, what quadrants am I going to draw it on? 1 and 2. Okay, your calculator figured this out for you. You've got to use your brain to figure this one out here. Now, it's not hard to flop this down here and draw the triangle. That has the exact same adjacent side, the x coordinate of 1/5. The question is, what is the measurement of that in radians? There are lots of creative ways of doing that, but remember, reference angles are always formed with the x-axis. So it's always better to compare either with pi or with 2 pi or 0. Okay? So we want to figure out this one right here and be able to say how we got it. Hop knows. Anybody else? A couple other people? Noah's halfway committed to knowing the answer. Nathan, have you got it? What do you think you'd do? If I want to know this angle right here from standard position, so it's got to go all the way around here, and what I do know is that this one is 1.36. So from here to here is 1.36, and I want to figure out all the way around that circle.
Could you take 2 pi minus 1.36?
Exactly right. So we're going to take 2 pi and we're going to subtract the 1.36. So we'll throw that in the calculator. So we'll do 2 pi, and I'm going to subtract that last answer there so I don't get any. So it's going to be 4.91. Okay? Any questions? Oops. Okay. Notice it says all. Are we done? Not done. We've got those answer sets right there. Then we've got to write the other ones. So the other ones are going to be x equals 1.36 plus 2k pi. And the last set is 4.91 plus 2k pi. Okay. Do me a quick favor. Somebody tell me what 2 pi thirds is. Give me a decimal for that. 2.09. And what about 4 pi thirds? 4.18? Okay. Everybody watch. Okay, I'm going to circle these numbers. 1.36, 2.09, 4.18, and 4.91. Okay, now watch. See this guy right here? I'm going to go to y equals. I'm going to clear this off. And I'm going to type in 1 divided by cosine squared. Wouldn't that be secant squared? Oops, squared. Okay. And then I'm going to do minus 3 and then parentheses 1 divided by cosine. Wouldn't that be minus 3 secant? And then I'm going to write minus 10. Good? And I could come down here and I could write y2 equals 0, but what is y equals 0? It's the x-axis. It's going to take a while. That's 0. That's 2 pi. How many places does it cross in? Crosses in 4. Okay, I'm going to hit trace, and I'm going to type in 1.36. Where should the cursor just immediately jump? Okay, we're hoping that it jumps to that very first one right there. Okay, and it is, oops, it's right there. Okay, this is really steep, so let's be a little bit more accurate. Let's do calculate. I'm going to do an intersection. Okay. Whoops, I'm going to do a 0. .35 and 1.37. And there's our guess. It's going to work for a second. Okay, somebody who's still got that up on your calculator, isn't that exactly where it is? Okay, we can make this look a little bit better by doing this. Pretty wild looking graph. If I hit trace here, 1.36. Pretty darn close. The next one is 2.09. Really close. 4.18. Really close. And that last one, 4.91. Pretty darn good. They're off just by rounding. Okay, if we were to use like 4 decimal places or something like that, it would just hop from point to point to point. Okay, any questions? Okay, really quickly, let's take a look at number 16. What did you do? What did you do?
Sine and the cosine on the same side.
Okay.
Eventually I got to tangent x equals root, or radical.
Very good. Okay, everybody watch, please. Here's what you could do. Here's the quickest way to do it. Remember I said you should be a little bit careful dividing by trig functions because you don't want them to cancel away. It does cancel from this side, leaving a 3, but does it completely cancel from this side? Nope. But what is sine squared x over cosine squared x? Tangent squared x, which if I take a square root, now you've got to be a little bit careful here. If I take a square root of both sides, I get the tangent of x equals plus or minus radical 3. So we want to know, where does the tangent of x equal radical 3, and where does the tangent of x equal negative radical 3? Okay? There are two sets of answers, yep. Okay, any questions? All right.